Here are solutions for quiz 7 for Math 95. In the first problem, we are given radicals, different things under the radicand, and asked to add them together. What not to do? Don't add up 8 and 32 and say this is the square root of 40. You might see that and be like, oh yeah, and then square root of 40 is 2 root 10. I could simplify that. No, don't do that. Square root of 8 plus the square root of 32 is not the square root of 40. You cannot simply add these two numbers. Instead, the only way you can add up square roots is if they have the exact same thing underneath the radical. They don't, 8 and 32. But I can simplify each of them in hopes that I will end up with the same thing under the radical. So to simplify the square root of 8, maybe I'll do this out here. Let's simplify. The square root of 8, well, 8 is the same as 2 cubed. So if I do my good radical, bad radical trick, I think about it like I got 3 of these 2's, I put 2 of them over here on the good side, and then I got 1 left over for the bad side. And the square root of 2 squared is just 2. So what I get is that the square root of 8 is really just 2 root 2. And then to add to that, and then I need to add to that the square root of 32. Well, let's see. Square root of 32, if you do some prime factorization, what you'll find is 32 is 8 times 4. 4 is 2 times 2, and 8 is 2 times 2 times 2. So the square root of 32 is the same as the square root of 2 to the 5th power. So when you do your good radical, bad radical trick, you put 2 of the 2's over here, and then you have 3 left. You realize you can put 2 more over here. So you're left with just a single 2 out here. Each of these 2 squareds underneath the square root cancel out to just give me a 2. So what I get is that this is 2 times 2 times the square root of 2, aka 4 root 2. So really what this question is asking me to do is figure out what's 2 root 2 plus 4 root 2. That is something I can handle. I just got to think about it like I got 2 of these things, these square root of 2 things, and I'm adding 4 more of these square root of 2 things. So in total I got 6 of these square root of 2 things. So right here would be my answer. On the next problem, we essentially do that same thing. Let's see here. We're going to need the prime factorizations of 81 and of 54. It turns out that 81, should I do this somewhere? I guess. Maybe I can squeeze it in here. 81 is 9 times 9, and 9 is 3 times 3. So really what I get is 81 is 3 to the 4th power. And similarly, 54, well, it's an even number, so it's 2 times something. Think about it long enough, you'll figure out that other something is 27. And 27 is 9 times 3, 9 is 3 times 3, so 54 is 2 times 3 cubed. And so what I then do is I got to simplify. Guess I could do that off to the side here. I need to break this up more so I can see where one problem stops and another one starts. Let's simplify the cubed root of, instead of 81x to the 5th, I'm going to think about it as 3 to the 4th x to the 5th. And that's because 81 is just 3 to the 4th power. And so if I break that up into good radical, bad radical, each being cubed roots in this case, I say I got 4 of these 3's. I need groups of 3 to put them on the good side, so I'll put 3 of those 4 over here, which leaves me with 1 over here. Similarly, I got 5 of these x's, put 3 of them over here on the good side. Now I only have 2 left. I don't have enough to make another trio, so I'll put those over here. And this simplifies. The cubed root of 3 cubed is just 3. Cubed root of x cubed is just x. And so I get 3x times the cubed root of 3x squared. And if I do something similar, I can figure out the cubed root of 54, x to the 5th. Well, 54, as we saw in our prime factorization over here, is 2 times 3 cubed. So really I'll think about it as 2 times 3 cubed times x to the 5th and allocate those factors into a good radical and a bad radical. 2, I only have 1 of them stuck on this side. Shoot. This is not going to work. Alright, I'm going to have to change this problem. I'm going to have to make this 24. And if I make this 24, what you will get is this is 2 cubed times 3. Because 24 is 8 times 3. I should just redo this whole thing. And 8 is 4 times 2, which is 2 times 2, the 4. So 24 is 2 to the third power times 3. So really over here, I have 24. All right, I'm going to have to redo all this. Hold on one sec. All right, so hopefully I fixed the little part I screwed up on. Instead of 54 in this problem, I want 24 in this problem. But all that'll change is this prime factorization. Right? Instead of 54 being whatever we figured out it was, 24 is 2 times 3 cubed. No, it's not. God. It is, maybe I can just erase that last part. All right, now I got that all fixed. I just changed the problem. Instead of being 54 under the radical here, I made it 24 under the radical here. So for my prime factorization, I'll say 24 is 3 times 8, 8 being 4 times 2, 4 being 2 times 2. So 24 is 2 to the third power times 3 to the 1 power. So when I simplify it, it'll work out slightly differently. I'll get 2 to the third. I guess, yeah, I'll just write that. I want the cube root of 2 to the third times 3 times x to the fifth, because 24 is really just 2 to the third times 3. And the way I'll simplify that is kind of my good radical and my bad radical. And so I'll be like, I got 3 of these 2's. I need 3 to put it on the good side, so I'll put all 3 over here and nothing left for over here. For the 3, I only have 1 of them, so I'm stuck putting it over here. For the x to the fifth, I can put 3 of them over here, and I only have 2 left. Not enough to make 3, so they have to go over here. And so the cube root of 2 cubed is just 2, and the cube root of x cubed is just x. So I get 2x times the cubed root of 3x squared. Break these up a little bit. All right, and now I think I have enough information to finally do this problem. So I come back over here and I say I need the cube root of 81x to the fifth, but I just figured out that that was equal to 3x times the cube, that's 3x, times the cubed root of 3x squared. And I want to subtract the cubed root of 24x to the fifth. But the cubed root of 24x to the fifth, I simplified over here and got that it's 2x times the cubed root of 3x squared. So I got 3x of these things, and I want to subtract 2x of these things. 3x minus 2x is just x. So I get x times the cubed root of 3x squared as my final answer. All right, moving on. Multiply the following. So when you multiply these, you're thinking FOIL. You have to multiply this times this, this times this, this times this, this times this. But you might recognize that we have a special form here. We have what are called conjugate pairs. Something plus something times something minus something. You FOIL them all out, you get that the square root of 5 times the square root of 5 is just 5. But the square root of 5 times the square root of 4 is 20. So this times this gives me negative root 20. And this times this gives me positive root 20. Maybe I should write it out. Minus the square root of 20 plus the square root of 20. And then root 4 times root 4 is 4. Positive times a negative is a negative. So what happens is that negative root 20 and the positive root 20 cancel each other out. Anytime you have these conjugate pairs, that'll end up happening. So those two cancel each other out, and I just get it's 5 minus 4, aka that entire mess simplifies all the way down to the number 1. What about this one? Unfortunately, it doesn't simplify quite as nicely. For this one, I think the best way to think about it is kind of like this week's perfect problem, where you first convert things into exponent notation. So you say I got x to the 1/2 plus x to the 1/3, and I'm multiplying that by x to the 1/2 plus x to the 1/6. And then you FOIL that thing out. If you don't want to FOIL, you can use this box method that I'm setting up here, where you put one of the products kind of as the column headers and one of the products as the rows, and then just fill in the 4 boxes. X to the 1/2 times x to the 1/2 is x to the 1. X to the 1/2 times x to the 1/3 is x to the 5/6, and that comes from the fact that 1/2 plus 1/3 is the same as 3/6 plus 2/6 if we get a common denominator, and 3/6 plus 2/6 is 5/6. X to the 1/2 times x to the 1/6, I guess I should do that again over here. I get that that's 3/6 plus 1/6, aka 4/6, aka 2/3. So this is x to the 2/3 power. And then finally x to the 1/6 times x to the 1/3. Well, 1/6 plus 1/3 is the same as 1/6 plus 2/6, which is the same as 3/6, which is the same as 1/2. So I get this as x to the 1/2 power. So what I get from my answer is this thing is equal to x plus x to the 5/6 plus x to the 2/3 plus x to the 1/2, or I think I'm going to ask you to write this in radical notation. So we'd say it's x plus the 6th root of x to the 5th power plus the cubed root of x to the 2nd power plus the square root of x. Came from all these exponents. So right here would be our final answer. And I guess that's the end of this quiz.